Okay, so what I want to do, and you can still see my whiteboard?
Yes.
Okay, so what I want to do is just go over some basic review of rivet information, then we'll get into bending, a bend scenario and calculating the layout of a bend. So let's just kind of start here with a 3 rivet. So if we have a 3 rivet, what is the actual diameter in fractionally of a 3 rivet?
3/32.
Yep, 3/32. And what is 3/32 decimally?
Let's take a look here. Looks like 0.937.
0.09, right?
0.0937.
Yeah, 0.09. We'll call it 0.093.
Okay.
What drill bit do we use for a number 3 rivet?
A 40.
A number 40 bit.
Yeah.
And what color is the cleco used on a number 3?
That'd be silver.
Yep, silver.
Silver cleco.
Okay. So then we'll go to a 4 rivet. A 4 rivet is what fractionally?
It'd be 4/32 or 1/8.
4/32, which is kind of a dumb number. So what do we call 4/32?
1/8.
1/8. Perfect. And what is 1/8 decimally?
That would be 0.1250.
Yep, 0.125. And what drill bit do we use on a number 4?
That'd be at 30.
30. Yep, 30. And what color cleco is a number 4?
That'd be the bronze cleco.
Yep, bronze. Some be bronze, brass, one of the two, something like that. Okay, so now we have a number 5 rivet, and what is that fractionally?
That'd be 5/32.
Right. You're buzzing through these, so that's good. And
Yeah.
decimally 5/32 is what?
That would be 0.1562. 0.1562.
Yeah, we'll go 0.156. And then what drill bit for a number 5 rivet?
Go with the 22.
Nope.
20.
21. 21 drill bit for number 5, and a cleco for number 5 is black.
So on this chart here, there's a 22 drill bit
Right.
for 0.1570. Is it? What do we
Yeah,
still go
it
with?
needs to be. That would still be bigger. So a 5/32 rivet would probably fit in a number 22 hole, but
Okay.
it fits a lot better in just a slightly bigger hole. A 21 would be a very slightly bigger hole than a 22,
Yeah.
and it fits a little better in there.
Okay.
And then last but not least, a little bit more uncommon, but still a common aviation rivet is a 6 rivet. A 6 rivet is 6/16. That's a dumb number, so we call it 3/8. 3/8 decimally is what?
I think would it still be 0.1875? No.
Actually, and I lied about this. So, because
Yeah.
it'd be 6/32, so it'd be 3/16, right?
Yeah, right.
I tried to trick you.
Yeah.
3/16, and 3/16 is what decimally?
It'd be 0.1875.
Sure, 0.187. That's probably close enough. And
Don't be tricking me because I'm not going to correct you. I'm just going to be lost.
no. I just kind of.
What the hell is he talking about? Okay.
So
Okay.
a number 6 rivet uses a number 11 bit,
Oh.
and the cleco for number 6 is gold. So the one thing I try to caution people is to make sure. A lot of people call clecos for number 4 rivet, they call them gold, which is fine if all you have is 3, 4, and 5 clecos. But if you do happen to have any 6 rivets, or actually any gold clecos. There's a big difference between a gold cleco and a bronze cleco.
You said you use an 11-bit? Is that what you said?
Yep, a number 11 bit for
A 6.
for a 6.
Okay.
So now, let's say we got two sheets of aluminum here, and one of them is a 40, and let's say the other one is a 25. So we got 2 sheets of aluminum.
Okay.
And we want to know what diameter rivet we're going to use. So we know we're going to use a protruding head rivet. So our rivet is going to go like this. Eventually, when we're all said and done, before we drive it, our rivet's going to look like that. So we're going to use an MS-20. It's a 470, and we'll say it's an AD rivet. But now we need to figure out what size rivet we're going to use with these 2 sheets.
Okay,
so the formula, do you remember the formula?
Yes. Well, for the diameter, we're going to do 2.5 to 3 times the thickest sheet.
Yep. We're going to do 2.5 to 3 times the thickest sheet. So the thicker of these 2 sheets is what?
0.040.
Right. So the 040 is a thicker sheet. So 2.5 times 040 is what?
Oh, let me do the calculations. Yeah, 0.1.
0.1. And what is 3 times 0.040?
0.12.
0.12. So that's kind of our scale. That's our scale. So we're going to say that's our scale. You know, we have all sorts of scales here.
Right.
The rivet we want to use is going to match somewhere in here. So a 3 rivet, if this was a scale, where would a 3 rivet fall?
It'd fall beneath.
Right. So a 3 rivet would fall just beneath, like right here. Where would a 4 rivet fall?
Just over.
Right. So
3.5.
in this instance, a 3 rivet is just barely kind of out of the scale.
Yeah.
And a 4 rivet is kind of right on the high side of the scale, because a 4 rivet is 0.125 inches, and we figured that we would want to use a rivet that fell somewhere in the scale. So a 3 rivet is right on the very kind of low end of the scale, give or take. We're kind of, you know, using some interpolation here. A 3 rivet is right on the low end of the scale. A 4 rivet is kind of right on the high end of the scale. I always say, if when in doubt, kind of use the bigger of the rivets. So we know based on this that we are going to use a 4 diameter rivet.
So what's your logic for using the bigger as far as diameter goes?
Just bigger is stronger, you know, bigger is stronger. In this instance, you wouldn't be necessarily wrong depending on what the part was. I don't think you'd be wrong if you used a 3 rivet, depending, like there again, it kind of depends on what the part is. If the part is some kind of structural part, I would definitely say, yeah, go bigger. If it's like a bracket that holds, you know, that holds an ashtray on or something, you know, if it's not structural, maybe you could get by with the 3 rivet. So you kind of get to use your common sense. But I would say when in doubt, especially if it's something structural, use the bigger, stronger rivet.
Is it ever okay to not have continuity? Like if it's that close, you got some, half dozen of one, half dozen of the other. Is there always continuity with
Yeah, they're usually going to always be the same. If for nothing else, we like that just for purely aesthetics. So when always use the same. There are some instances where every once in a while you have one rivet that's bigger, and usually it's because it's holding, maybe it's on a bulkhead or something like that, so it uses a little bit bigger rivet. So when in doubt, go big. So we'll use a 4 rivet. So now I'm gonna erase some of this here. I don't want to erase all that. I'm gonna erase just some of this here. Damn it. So now we know that we're gonna put a 4 rivet in there. We need to figure out what length. So what's the formula for length?
It would be the sum of the two. I think it's the sum of the two sheets plus. Well, let me make sure. It'll be this.
So we know
it's the sum of all sheets plus 1.5 the diameter of.
Correct. Because we know that when we drill a number 30 hole, here, we put in a 4 rivet. Before we squeeze it or pound it, there should be 1.5 D sticking out the bottom. So our formula becomes the sum of these two sheets plus 1.5 diameter.
Right.
Now, the diameter of our rivet is what?
It would be, we're running 4, so 4 30-seconds.
4 30-seconds. What is 1.5 times 4 30-seconds?
Let me do it on the calculator here. Times. Hold on a second. I'm trying to find the decimal equivalent to 436.
Well, but let's do it this way. Look at my whiteboard.
Okay.
A lot of this you should be able to do in your head. A lot of this kind of easy stuff you do in your head. So a 4 30-seconds rivet is the same as saying 8 64ths, right?
Okay. Yep.
Correct. 8 64ths is the same as 4 30-seconds.
30 seconds. Okay.
So what is 1.5 times 8?
12.
12. So it's 12 64ths. Now we have to, that's a dumb number. 12 64ths is a dumb number. So 12 64ths is the same as saying 6 30-seconds, which is the same as saying 3 16ths. So 3 16ths is our fraction. Now we can convert that fraction to a decimal, and what do you get?
That would be let's see, 1.875. I should know that one as well. Yeah,
Chris, you did this yesterday. Be very careful how you said that. You said
1.1875. I'm sorry. Yes,
you really need to concentrate, though, that where you put that decimal point makes a huge difference. So be really careful about when you're saying your decimals.
Okay.
So if we add all these together, what do we get?
.272.
Doubt it.
All right.
Does your calculator not work?
Well, let's see. I got 0.040 plus 0.025 plus 0.187 0.252.
That just passes the eye test a lot better than whatever you said at first. I wonder if you got a bad calculator, because your calculator is always making errors.
I doubt if it's the calculator.
Well, that's why I was waiting for you to. I was waiting for you to go there. It might have been operator error, but anyway,
Yeah,
that passes the eye test. That passes the eye test a little bit better, because that's what I guessed it would have been.
I get it.
Okay.
Math was never my strong point, so I'm not.
That's fine. So now we see this number here. When I see that number, this is what I think of. If I see 0.252, I just think of 0.25.
Right.
And when you see 0.25, what do you automatically think of fractionally?
A quarter, 25%.
1/4.
Yeah.
So now, length of rivets are measured in what fraction of an inch?
16ths.
What is 1/4 in 16ths of an inch?
4/16.
4/16. So that tells me that we should be using an MS-20 470 AD 4-4.
Okay.
That's going to be the rivet that we're going to use in those two sheets. So we're going to be using a 4-4.
Makes sense.
So that's some real basic rivet information. You know, we could add what our minimum edge distances is. I did that in another video, but we could add what our minimum edge distances are. We could add what our minimum pitch is. We could get into all that sometime, but for now, that's a good lesson on rivets. Okay. Chris, do you have any questions on that?
No.
Okay.
Good.
So now let's do our next part. We are gonna bend. We have a piece of metal here. And I'm gonna just do my excellent artwork.
Pretty good at that.
So I'm getting better. So this is what our final product should look like. This is our 3-dimensional mold drawing. So we're gonna say it's 3 inches. Each leg is 3 inches. And let's say this leg is 6 inches. And let's say this is 3 inches. Okay, we're gonna say that all these bends are 90. So we're going to say both the bends are 90, and we're going to say that it's 2024 T3, and it's 32 thousandths thick. So we have our dimensions. And we kind of know some stuff about what this final product will look like. So we are going to go here, and we're going to say what material is this made out of?
2024 T3 aluminum.
Yep, 2024 T3. What is the thickness?
0.032.
0.032 inches. We'll add that in there just because.
Okay.
So knowing that, and we have our textbook here. We have our FAA 8083 Airframe Volume 1 textbook. On page 4-62 in the book is a chart that tells us what the minimum bend radius is. So what would our minimum bend radius be?
It'd be 0.12.
0.12 would be our minimum bend radius.
Yeah.
On this, we don't have to use our minimum, but what do you want to use as radius?
I like 0.25.
Okay, 1/4 inch.
Yeah.
Okay, that's okay because that is more than our minimum, so we're okay. So now we have we picked our radius there.
Yeah.
What is the next thing we need to do is we need to figure out our setback.
Yeah.
So we need to figure out setback.
Okay.
And the formula for setback, is K value times radius plus thickness. So we have a K value chart, which is nice and handy in the FAA 8083. And it tells us that on 90-degree bends, which these are, the K value is 1. So since we have a K value of 1, basically, what does that mean we get to do to this formula?
We just get to omit the K value and go with the radius plus the thickness.
Right. Because the K value is 1, anything times 1 is going to be itself. So we get to make this formula. A lot simpler.
Right.
So our setback becomes radius plus thickness. And what do you get if we add the radius and the thickness?
So it would be 0.282.
Yep, 0.282 becomes our setback.
Yep.
So now we can measure what our flat sections will be, right? Because now we know our setback. So flat 1, which I'll do it here in red. This is flat 1, this is flat 2, and this is flat 3. Yes. So what would the measurement of our flat 1 be?
It would be the mold line dimension minus the setback number.
Mm-hmm.
So it would be, you have the number out there already.
Well, I just did it in my head, but is that what you get?
No, but I know you've seen this problem like a million times, so I know that's right.
No,
yeah.
I really haven't. I just did it in my head. I just took 3 inches and I subtracted 0.282, and I just did it in my head, and I just can tell that that's 2.718. But do it on your calculator and see if because I could be messed up.
Yeah, you could.
I could. No, I really could.
I doubt it. On this problem, I doubt it. Yeah, right on.
Okay. So now we can do flat 2.
Okay.
So what do we have to do a little different on flat 2 that we didn't do on flat 1?
Well, we have to take in consideration that there's 2 setbacks.
Right. There's 2 bends. Flat 2 has a bend on one side of it, but it also has a bend on the other side. So because flat 2 has 2 bends that touch it, we have to subtract 2 setbacks. So we have to take our mold dimensions, which is 6 inches, and we have to subtract 2 setbacks. So you can do it in your calculator. I'm going to do it in my head and see what I get.
That's why you're getting the big bucks.
Well,
so I got 5. I got 5 point. Oh, here, go ahead and do it.
Well, I get 5.4 something for 5.4 something. What do you get in your calculator? Help me out.
I got 5.436.
5.436. That looks very reasonable to me. So now we know flat 2, and then we get to do flat 3.
Essentially,
And
the mirror
what will
image
flat
of
3
that.
be?
It's going to be the mirror image of flat 1, since we have the same measurement. So.
Right, it'll be the same as flat 1. Now we get to figure out our bend allowance. Our bend allowance is a real complex formula if we want it to be. The bend allowance is a complex mathematical formula. However, in our textbook, FAA 8083, on page 4-66, they give us a handy-dandy, nice little chart for figuring out bend allowance.
Yeah, they do.
So using the chart, what do you get for bend allowance?
It's looking like, hold on a second here. Let's see. What's I said this? 0.170.
How did you get that?
Hold on a minute. No,
Remember, it's thickness in the y-axis.
Yeah.
And then your radius of your bend in the x-axis. And you did a 1/4 inch bend, 1/4 inch radius. So you got to go all the way to the 1/4 inch.
Yeah, 0.41 point. I'm sorry, 0.415.
Correct. 0.415 becomes our bend allowance.
Right.
So now we have all of our answers. We've basically figured out all the math.
Right.
So now before we can make this piece, we have to draw a blueprint of what our flat sheet is going to look like. Correct. So I'm going to actually make my life easier here. Our flat sheet will be a rectangle, correct?
Correct.
So our flat sheet will be a rectangle. It'll end up with how many bend allowances on it?
2.
Right, 2. So this isn't to scale, but there'll be like 1 bend allowance here, another bend allowance, kind of like that, right? Not really to scale, but it kind of gives us an idea. So what will the, we'll do this here. This will be flat 1. This will be flat 2. This will be flat 3. Now, what will the dimension of this line be right here?
I don't see where you're going. Okay, that'd be 3.
That'll be 3 inches. Okay. Then we'll have 2 bend allowances here. What is the measurement of those bend allowances?
So it'll be 0.415 for each.
Yep, 0.415 for each. So now we're going to also have, we'll have a flat 1 dimension, we'll have a flat 2 dimension, and we'll have a flat 3. So what will flat 1 be?
2.718.
And what will flat 2 be?
It'll be 5.436.
And last but not least, flat 3?
2.718 again.
Yep. Okay. And then the last thing we're going to need to do is add all those up together to get our the complete length, which would be what?
11.702.
Okay.
When I got.
Sure. I'll buy that. I'll buy that. So now we know all these dimensions. So now we can go grab a piece of aluminum, 2024 T3 and 32 thousandths, and we can shear a rectangle. We can shear a rectangle that's 3 inches by 11.7. For all practical purposes, 11.7.
Okay.
Then we can draw on our piece of aluminum. We can make measurements with a dial caliper and make measurements and draw where these bend allowances are. Right? And then what's the last thing we want to draw on there?
Our sight lines.
Our sight lines. And for those, we're going to have to use our radius as our measurement. So we picked a radius of 1/4 inch or 0.25.
Right.
So we're going to know that we're going to have to bend this twice. So we're going to end up sticking both ends into the brake. So again, I always mark an X on the end that I'm going to stick into the brake.
Okay.
Since this one, we're going to stick both ends in the brake, I'm going to have 2 X's. So then what we'll do is we'll have to draw our sight line. We know that our sight line is going to be one radius as far as this flat one, it'll be one radius to the right of this first bend tangent line.
Right.
So here's our first bend tangent line right here. So it's going to be one radius to the right. So we're going to measure 0.25 from this bend tangent line and draw our sight line. Okay. Then we're going to do the same thing over here. We're going to measure 0.25 from this bend tangent line and draw our sight line. Now notice those sight lines are not exactly halfway in our bend allowance.
Right.
Our bend allowance, is this area right here. Our bend allowance. The sight line is not quite halfway. Actually, I drew it wrong. It should be, I'm going to make this more realistic. It should be over halfway. If I wanted to be more realistic here, it should be over halfway because this bend allowance is only 0.415 and our radius is 0.25. So our radius is more than half of this distance of our bend allowance. So I kind of maybe over exaggerated it, but you get the message. So when we have our brake, here's the nose of our brake. And let's say we put a couple shims in there. We shim it so it's going to do 1/4 inch radius. So let's say this brake is set up so 2 shims does 1/4 inch. Then we put our, well, I'm not drawing very straight lines. We put our piece of aluminum in there. Okay.
Okay.
Now we clamp it down.
Yeah.
Where will, let's say we're doing this flat one, where
Okay.
will this bend tangent line right here be in this picture?
It's going to be to the left of like where you drew the shims.
So yep, right about here, right about where the bend is going to start is where that bend allowance will be. Yeah. Then we're going to be standing above it, and this is not to scale, but our eyeball is going to be right above it. And we're going to be looking straight down the nose of the brake. And then that is where our sight line would be. So our sight line would be right there. And our other bend tangent line would be like over here somewhere, right? So that right here is a cross section of that. So what I drew right here is on the brake, a cross section of that. So we would look straight down the nose of our brake and look at our sight line. And then once we have everything the way we want it, then we pull this up and we bend the whole thing that way. Actually, Yeah, same. It would be the same difference.
Right.
Does that make sense?
Yeah.
That's all there is to. That's all there is to figuring out rivets and figuring out how to do the layout for bending. So for those of you that are watching this video on YouTube, please like this video, subscribe to my channel, and look forward to the next one. Thank you.